In this video I'm going to set up a full tool chain for graphical user interface code development within embedded Linux on a board with a display module. Qt or Qt, depending on how you pronounce it, for embedded Linux provides the standard Qt API for embedded devices with a lightweight windowing system. Embedded Qt applications can write directly to the frame buffer, so there's no need for GNOME or any other X Windows system, which saves on system memory. Qt applications need a server application to be running, or for an application to be the server itself. The good news is that any Qt for embedded Linux application can act as the server. When more than one application is running, any other application that is started up can connect to the same server application. The server manages pointer handling, character input, and screen output. I'll use Qt Creator to compile C++ code and develop the cross-compiled code directly to the Beaglebone over the network using a single button press. Qt Creator can be used to graphically lay out a user interface. Then, using Qt's signal and slot system, we can set up asynchronous event handling mechanisms. Qt's meta object compiler, or mock, then automatically generates the required infrastructure. Finally, in the video, I'll show you how we can set up a remote debugging functionality that allows us to pause an application that is running on the embedded system and interrogate its state information. So previously you saw that I downloaded the latest Angstrom image and installed that on the SD card and booted the Beaglebone with that image. What I'm going to do next is I'm going to install a toolchain, and for this we can get this from Angstrom. Distribution, same site, org/toolchains. And you have to pick a toolchain that suits your platform that you're on. At the moment I'm using a Linux distribution. It's a 32-bit Linux distribution that's running within VirtualBox on 64-bit Windows 7. So we need to install a version that's suitable for my Linux on my desktop machine and the Beaglebone. So the Beaglebone is running ARM 7A. We saw that before. I think I'm still connected to it. So ARM 7 v7.1. And on my local machine I'm using i686 Linux 32 686. So I need this version, and I want the version with Qt installed. So it's 134 megabytes, and this is the version. So you'll see that every second one has Qt, and this is the one that I want. So it suits my Linux distribution and the ARM 7. So I'm going to download that, save file. So that's done. So we need to untar it to the root folder of my Linux desktop machine. So it's, just check this there, it's the first file, Angstrom, the small a. It's about 134 megabytes. So the way we do this is sudo tar -c space. We're going to go to the root directory, minus x jf, and then the file. Okay, so that should work. Password. Okay, it seems to be working. Yeah, it worked. So there's a new Angstrom directory there. Okay, that's where just a lot of the files have gone to. So that means that we now have our tool chain installed there. If we go into, oh yeah, you can see our full tool chain is there, and we'll use that. The next thing we have to do though is we have to set up the environment. So we have to use /user /local /angstrom /arm /environment setup. Okay, so that means now that our tool chain is set up in our environment, and really we need to have this, if you want to use this over and over again, and especially if you want to build applications in Qt Creator and use them, you're going to have to automatically execute this environment setup when the machine is starting up for the first time. So once we've done that, we can check. Okay, QMake2 is working. So everything appears to be in order. So next I want to install Qt4 embedded on the Beaglebone. And OPKG I'm going to use. Make sure I update the list. Update. PKG install Qt4 -embedded embedded. Okay, so after updating the list, if you don't update the list, it probably won't find Qt4 embedded, but I'm just going to leave that run now. So that's Qt4 embedded on the Beaglebone installing. I'm going to go back to my desktop machine now. So on my desktop machine, I'm going to write a first Qt application. So again, this is part of the deployment guide that's here. I'm just going to follow the steps that are here just to make sure they work. QMake2 is working, if you remember, and what I'm going to do now is I'm going to make a very simple application that we're going to deploy to the Beaglebone. So I'm just going to use the example that's here, and I'm going to do exactly what it says there, but just to follow through on it. And I just want to do one thing on the Beaglebone. So it says make a directory, QTE example, and into this directory, and I'm gonna just VI QTE example.pro. I just prefer VI. So VI QTE example.pro. So this is the project file. And we just want to add a few lines to this. Template equals app, and the next line, sources equals to main.cpp. Okay, that's it. Escape :WQ, and then more Qt example of pro. So you can see that's just created a file with those two lines in the entry, and that's the QTE project Qt project file. Okay, so the next thing we need to do is to add the C++ file, and this is going to be called main. So vi main.cpp, and you can see we referred to that in the project file. And in here, I'm gonna just try and cut and paste it and see does it work. This is the code we want to copy right to there. Okay, just have to fix the very top. Oops. dd deletes a line in VI. Just back up to the top. Ooh, one too many. I don't know what's happening here. So let me save this, and I'm gonna fix it again. Okay, a bit of a mess there, but it's fixed now. Not very good at VI. And that's one of the reasons that I want to install the Qt Creator. It'll make it a lot easier. So that's the code. #include main is there. Escape :WQ, more main.cpp. So there's our application there. So we should be able to, if I just ls in my directory, we should just be able to go QMake2, and that created the make file, and we can see, so QMake2 created the make file from the project file. So if we go more make file, You can see that it's used the environment variables and has our main.cpp file listed there and has everything set up. So that looks like it worked perfectly, and it has all the directories set up correctly. You should see user local angstrom built and so on. So quit out of that. And once we've got the make file, we should be able to just make. Okay, and that was very quick. And in this directory, we now have an executable, and it shouldn't work on this machine. Qt example, cannot execute binary file. And this is because we've actually built it for the Beaglebone, so it's not going to run on the local desktop machine. So we need to transfer it across to the Beaglebone. I'm just going to have to wait a minute until this is finished installing. But you can see that because I need all the libraries that are part of Qt4 on the Beaglebone, so it's just going to take a minute for that to take place. So I want to disable GDM and GNOME from starting up on boot of the Beaglebone, and the way I would normally do this is something like this: update -rc.d -f gdm remove Windows Manager from remove. Oops. Okay, now that's the way I would normally do it. Update -rc.d -f gdm remove, and that removes the links for GDM. The problem is I can reboot this and you'll see, but it still boots, and that's because that angstrom is using a different location. And the way we have to remove this, which is, well, I hadn't seen it before, is we use system control. System control, disable GDM.service. Okay. So now I can reboot. Okay. So now when it has rebooted fully, you'll see that it doesn't actually go past here. It stays with the angstrom login screen, but it doesn't actually start up the windowing environment. So I've secure shelled into the Beaglebone now, and you can see that it stays like that. It doesn't start up GDM at all. I've made a mistake. If I vi, I'm missing a line. It was in the example. Couldn't paste there. Return app.exec. Escape colon wq, qmake 2, and make. Okay, I'm going to FTP that again. SFTP to root at 192.168.1.108. Root password is root. I'll put it in the same location, CD desktop. Okay, so that should be my desktop. Okay, and if I do Qt example minus QWS, there we go. Everything's working now. So there's my application. It's working. I have my Hello World button. I should be able to press it. It's pressing. You can just barely see the change. One thing you'll notice is I have a very serious problem with my mouse. I'll just show that with my stylus. My mouse is nowhere near my stylus. So we've got another problem we need to solve. So I'll solve that now as well. Okay, so we need some way of calibrating. I wonder if there's a way to get rid of the banding. Okay, so that's running, so I can kill that by hitting Control C and it dies there. So we need a way of calibrating the screen. The best way I found of doing this is very, very reliable. Is I installed tslib. Spell right. tslib calibrate. Oh, I seem to have it installed. Must be part of the more recent release. It's up to date. I'll cancel that out. Okay. So let's go. ts_calibrate. Okay, so quickly get my pen out. gives me TS calibration utility. Touch here, touch here, touch here, touch here, and touch in the center. Okay, so that has created a calibration file. TS underscore TS underscore test. Okay, not having a good time with it. Touch the screen to move the crosshair, and it's working very accurately now. So we can go to draw mode, and you can see test. Okay. So that's working well. Okay, quit. So that has set up our environment. Now the only problem is that we need a way of actually exporting this so that we can export the driver to so that it's calibrated. So we can type it like this, and we do want to do this for our QWS, for our Qt server. So export QWS underscore mouse proto equals Linux input :dev/input /event 0. Okay, so that's mapping it. Okay, so now if we go back and if we go back to where, here we go, it's here somewhere, Qt example minus QWS, hit return. You can see now that my button is there and my mouse is exactly where my stylus is. So it means that we have access, we can maximize the window, or there's hello world. Close the window. I don't know what happens if I close the window. Minimize. Don't know what that does. Okay, so maximize kills it. That's close kills the window. So that's good. So that's up and running. So that means I have a full tool chain for compiling a Qt application and deploying it to my Beaglebone, and it has a calibrated touchscreen and everything works well. The only problem is you're not going to build a serious application in this way. So we need a way of actually having some sort of graphical user interface that allows us to build our applications and to create complex applications. And for this, I'm going to use Qt Creator, which is available for Linux, and it allows us a development environment, an IDE, very much like Eclipse. But the nice feature of it is that it has a nice user interface for designing our windowing applications. So I'm going to do that next. So one way to get Qt Creator is to go sudo apt get install Qt Creator. The only problem is that this is quite out of date, and it's quite an old version of Qt Creator, and I wouldn't recommend that you use this version because it doesn't have support for remote deploy to the Beaglebone, and that's a really nice feature. If you follow these steps that I have here, you get remote deploy to the Beaglebone directly, and also remote debugging using GDB server. So I think it's much better to go for a sort of more complex install, but to install the Qt directly from the website, Qt releases. So it's releases dot Qt project .org/Qt Creator. CREATOR. So Qt Creator latest releases. I'm going to go for the latest stable release, which at this point is 2.6.2. So download 2.6.2. And which version do I need now? Obviously it's Linux. It's not 64. So it's Qt Creator Linux x86 open source for my machine here. So I'm going to save link as and save it as that in my download directory. Okay, so that's downloading. It's 60 megabytes. So it's going to take a few minutes, 3 minutes to download, it says, 2 minutes. So I've got my binary file here. Just check the size. For some strange reason, the first time I downloaded this, the file was interrupted on download, and it gave a very strange error about not being able to find the access point before 1 megabyte. So we have to change this to be executable. Okay, oops. Okay, so that's executable now. It's a binary file that's executable. So we're just going to execute it. Okay, set up creator. Next. I will install it in this location. That's a good location for it. I've read it. It's ready to install. Finished. That was kind of quick. Qt creator. Okay, and it's bin directory there. So we could add that to our path. But sure, for the moment, Qt creator. Okay, so it's all up and running. It looks like Qt creator 2.6, so everything looks good. Help about. Yeah, Qt creator 2.6.2, and everything's in order. And there should be getting started, develop, examples. I've noticed this before, my examples. I think you have to install them separately, and tutorials. So there's a good bit of information there. About getting started. There's loads of information on the Qt website. So we're just going to build a very simple application and set up a toolchain. So the first thing we'll do is set up a toolchain. Now, bear with me. It's been a while since I've done this. So file. Let's create a new project. Actually, we'll create a new project for the local machine first of all. Qt GUI application. Yeah, that's fine. Choose that. Qt creator bin. I don't really want to work from there. I'll create a project directory here called Qt projects. Okay. I'll create a name project here called test. Qt test. We've only got one. I've only got one kit at the moment, so I'm just going to build it for my desktop for the moment. Main window. Okay. So this is a standard test setup. So you see the nice feature here. We can go into forms and create a form. Create a button here called. Let's create a button. Push button. And we'll give it a name. Test button, and we'll create a text, a line edit. Okay, give this a change object name. Test edit. So we've got our push button. So we want to go to the slot. So this is when it's like events in Java. When the signal that we want to generate is clicked. So we need a function that's the slot to handle that, like the event handler in Java. So we can say when the button is clicked, we want something to happen. So that gives us our on test button clicked, and we can say UI arrow. We should get prompting UI arrow. I called it test edit arrow set text hello Beaglebone. It's probably a bit long for the moment, so we'll build this and deploy it. I'll just build it, see if we get everything, save all, and just deploy it. Oh. Can I execute binary file? Okay, one of the problems is that it's already, because I've used the environment variables for the toolchain. So because if you remember right before, I said dot slash user slash local slash angstrom slash arm slash environment setup. When I did that, install a tool chain for Qt, which is the Qt compiler, which is only compatible with the Beaglebone. So we're actually building applications here now for the Beaglebone. Now I don't know if this is going to work on the Beaglebone, but sure, I'll give it a try. It's not an ideal way to do it. We'll try and improve that in a minute. So let's copy that across SFTP. So in my Beaglebone, I can see Qt test, so I can type /Qt test minus QWS, and you see, it appears. Good. So obviously this is working. I don't know if the mouse is, it is calibrated, yeah. So the mouse is calibrated. So I press the button and we get hello Beaglebone appears within the window. And I can also maximize, and that's about it. It's not a very exciting application, but it proves the concept. So I have visual design here, or user interface design here, and I get the output changes accordingly. One of the things that would be useful to do is to change the output, change the size to match the screen size. So geometry of it is, it's 480 by a height of 272. So that means now that it matches, whatever we develop here matches what we develop on the Beaglebone. The only problem with this setup here is that well, it's not very nice having to SFTP your application across and to run it in that way. So we want to set up a proper toolchain, and we want to set it up so that we have full access to build our Beaglebone applications and deploy them directly. I want to go in here into projects and manage kits, and I'm going to create a new kit. I'm going to call this Beaglebone. Name it Beaglebone kit. Generic Linux device. Oh, we haven't given a device yet. Sysroot, we'll talk about that in a minute. Choose our compiler. GCC. Path, and it's our file system. User. Local, angstrom, arm, bin. Not quite. Bin. So it's user, local, angstrom, arm, bin, and a G++. So that's the compiler that we want. Okay. Back to my kit. Beaglebone GCC. Okay. Debugger. Edit. Browse. This is going to be user, local, angstrom, arm, bin, and it's GDB. Okay. Device. We need to add a device. Add a device. So generic Linux device. We'll call it Beaglebone. The device is 192.168.1.108. User's logon root. Password is root. Next. Finish. Connected. Device test finished successfully. Close. And we can even see things like what the remote processes are. Now I'm getting the option if I want a desktop. So So I'm just going to go with the Beaglebone kit. I'm not sure. Debug and release. Next. Details. I will go with the same details. I don't need any version control yet. And debug, let me see. Beaglebone kit, deploy to remote device, run qtest on remote device. So let's go to our project. Build and run. Right, now, I'm not sure why that's the case, but I'd recommend that you close that project and start up a new project. Okay, so there's no files to deploy. I need to make a change to fix that. So edit, go back to my edit and let's just make something to make it, just do the changes again. This is 480 by 272. Beaglebone test. Okay, so that's done. File save all. So under run, there should be an option to deploy files to the project, but it's not there. And the way I found that you have to do this is you have to make a few modifications here. That's all fine. Target equals qtest2. Target dot files to we want to run it from the root directory on the target, and we want to add it to installs. Okay, so if I save this, go back to projects, we should see now that a local path file appears. So it's going to run in /root/home. And that's where we're going to do that. So can I maximize this? Yeah, I will. So we can check for free space, upload the files via SFTP automatically. It's going to execute that, and we want it to run on the remote device. We want to use -QWS, otherwise it's not going to appear. And that's it for the moment. I want to set a global variable, but I want to explain that in a minute. So let's see if that runs. Okay, deploy. It worked. So you can see on my Beaglebone over here, it's just popped up, Beaglebone test, and you will notice the same problem with the mouse calibration. The mouse is all over the place, but you can see it's working. Okay, so that's good news. So we just need a way now. Assuming that we've set up the TS calibrate from before, so we want to add in an environment variable, and it's the same environment variable that we set before. So for some strange reason, this is appearing as use system environment and details is grayed out, but you can still press it. So we want to add an environment variable, and it's QWS underscore mouse underscore proto. And the environment variable value is Linux input, capital I, colon, /dev /input /event 0. So that's that done. So use system, I don't know, yeah, okay, so that we can collapse it now. So use system environment and set QWS mouse proto to Linux event 0. So now if we execute the application again, you can see that this time it's running on the device, and you can see that the mouse is tracking my stylus exactly. Okay, and I can press the button, no problem, and I can do the same things with the windows and so on. It's hit maximized and so on. So there we've got our application executing now on the Beaglebone with one click, which is really good. So let's just try and just change the code so I can set up the debugger. So I'm going to edit the code slightly. Recording. Okay, I'm going to edit the code slightly. So go into my main window, and I want to have it so that every time that the test is updated, we get an updated variable. So let's give this button a name. Change object name. We call it test. Well, we call it Beaglebone. Beaglebone. Okay, so Beaglebone is our button, and whenever this is pressed, we want something to happen. So therefore, we have to go to the slot. We have to generate a signal, which is clicked. So whenever this button is clicked, it generates a signal, and then this slot captures that signal. So we want to do something there at this point. So we need to go back to our form. I'm going to create a text box again, wherever it is, line edit. Oops, make sure. Line edit. We'll just make it a little bigger, and I'm going to call this change object name. We can change it here as well. We call it Beagle edit. Okay, just to show that we're doing it like that. So what we want to happen now is that when the button is pressed, we're going to have a count that goes up every time the button is pressed. And the reason I want to do that is because I want to actually run the debugger against it. So we'll go to the slot. Well, let's do it through edit actually. We need to go, so this is our main window. That's where our slot is for the Beagle button being pressed. So within the main window .h, we want to set up a state to store the value. So we're going to create a private int count. So this is going to be our count value that we're increasing as we go around. And we want to create it as a state of the class so that it's not lost from within the function. And we need to initialize it, and we'll do that in the constructor of the main window. So we can say this arrow count equals to 0. So now we're initializing this with with value of 0 so that it's going to start counting at 0. So every time the button is pressed, we want to say this arrow count plus plus. If we created that as a local variable here within this slot, every time the slot was called, the variable will be destroyed. So we also want to display this value on the screen. So we can say something like this. Now we want to format it. And the way we can format it is to create a Q string. Qt string, temp is equal to, we'll just create an empty string, and we can do temp.sprintf. Printf, you can see we get lovely tips, autocomplete tips. Hello Beagle, and we'll say %d times. I don't know if that's going to fit, and the variable that we want is this count. Okay, so this dot count, or this arrow count, it's a pointer. And we also want to then place that into the text field. So this is UI arrow Beaglebone edit dot set text and the string temp. Is that it? I think so. So now I can save this, save all, and we can deploy it straight away to the Beaglebone, which is lovely with just one press. If it oh, hold on, stop this one. Okay, now deploy it. Oh, what have I done? The server said failure. What am I after doing? Application output stop. Okay, now we've killed the application that was running. Back to our application and the one press, second press. Press it again. As you can see, deploys it to our Beaglebone. We've got our Beaglebone test project. Hopefully our mouse is calibrated. Yes, it is. We press this and we can say hello Beagle 0 times, press it, and every time we press this button we're getting 6, 7, 8, 9, 10 times if I hit the button, and it's working correctly. So that's good news. So we've got a functioning application, functioning UI application that works like that. So it's saying hello Beagle 38 times, and we can kill this. Now what we may want to do too is remote debug this code. And we can do the same. We have the full tool chain here. So we should have GDB server installed on the Beaglebone. I just checked that on the Beaglebone. Yeah, it's installed, so we don't have to do anything. It's part of the standard build. So that's our debug server. So how do I do this? Do I need to make any changes? Hopefully not, in fact. Well, let's just go into our debug bit. We're already in debug build, okay, rather than release build. so we can start debugging. Okay, so it's running, everything's good. We're in the debug view, and I should be able to make a few changes. So we'll add, we want to see what value our count is. This arrow count. Oh, that's this, and we'll evaluate count. Add expression evaluator, count. And are we in debug view? We are. It's running. So we should be able to see that it actually, our application is running on our Beaglebone. And we can pause it. See that that's the case. Yeah, it's paused. And we should see that when I, okay. So it's using GDB server on the Beaglebone. So you can see it didn't work there because the application is paused. So we press release to retrace it. Maybe I'll pause it for a second, okay? And we go into this main window.cpp, and I'm going to insert a breakpoint here. Okay, so you can see there's my breakpoint. Breakpoint is in the function Beagle button clicked. So that should work, and we can add an awful lot. There's more debug windows that we can add as well somewhere. Where are they? Not too used to this. Debug log. Ah, there we go. There's the debug log anyway. That's useful to have. And registers. I don't know how useful that is. Well, these all appear down here, so it's easy to add them. Threads, modules. Let's add everything. Modules as well. Okay, so we can see the registers down here. That's useful to see. So it's paused. So they're the registers at this point in time. And we can see exactly where we are. So now I've added a breakpoint to line 23. So we want to find out what is the value of count as we run. So if we continue, it should run to the breakpoint. Okay, it's still running now. The problem is the breakpoint hasn't been met because I have to press the button because it's the slot for when the button is pressed. So I press the button. Okay, so here you can see that's the address of this. This is a pointer to an address. And there you can see there's the value of count at the moment. So count at this point, line 23 is 14, and it's going to loop around. So we can execute. I think we can just keep executing. So you should see count is going to go around. I can execute again. And then when I press, you see 14 appeared. I press Beaglebone. Okay, and rather than 15 appear, you can see now that it stopped again at the breakpoint. And 15 has appeared in the count, and the same is true again. We can continue it again, press again, and 16 appears in the count. So everything is working correctly. It works great as a debugger. Can remove that release point. You can see here it's talking to GDB server. These are everything that's the communication is taken between the client, the desktop machine, and the remote debugger. And we can see information about all of our libraries, our breakpoints. Oh, I deleted the breakpoints. Our registers at this point, the different threads that are running, and the links to the source files and so on. So all in all, it's a great environment for building Qt applications because we have our local environment where we can have the desktop space to build our user interfaces, and yet it's reasonably straightforward now once you've set up the full tool chain to deploy an application to the Beaglebone. So I have established a full setup for Qt GUI application development using Qt Creator that has full remote deployment and remote debugging capabilities. In the next video, I built a full input-output application using an LED for output and an I2C based accelerometer for input data that is attached to a threaded timer. I will also make the full source code available. Please follow the link here to see that video.